Welcome back. As I explained in my last video, I'm visiting a friend who's building a quarter scale model of Temptress, and I'm hoping to really understand how the shear clamp connects to the back and the front of the boat. Looking at the quarter scale model, you can see that he's chosen to take the shear clamp all the way through the transom. The part that I'm most impressed by is how fair that shear clamp is, and I'm trying to really get an understanding how deep to notch the transom so that the shear clamp isn't either bent not far enough or too far.
So, what do you do, Dan?
So, your position of the shear clamp is, in theory, dictated by the inner lamination of the transom, which gives you your size to trim down to. And the outer face is slightly smaller because that shear clamp's coming in, so you're beveling in from that. That is based on the fact that your transom is built proportionally to the correct widths and everything.
What are you saying?
It could be out, it could be, there's any number of variables involved. But ultimately what you're really trying to do is kind of sight down this timber and just bring this in slowly until you've got a good fair curve to that shear clamp, and that should be your ultimate governing dimension.
Okay.
Because if you do it to the inner lamination and that's too far in or too far out, you could have a kick to that shear clamp, which is then going to cause you all number of troubles throughout planking the boat. Or you could be too far in and then you're going to have a sudden sort of curve in on the boat. So these are the dimension of this is really your sort of guidance for being in the right ballpark, but really what you want to do is like cut that notch slightly shallower than you expect, and just like ease in slightly and like sight down this timber as you pull it in, which is another reason that wants to run through the transom, so you can offer it in, let it back out, take a shaving,
Got it.
back in and out, and you'll do that with all the topside battens as you set them in.
I want this batten ideally to line up with the inside edge of the transom, but the more important thing is to sight it down and make sure you get a nice fair line, because that's going to define the top of the boat.
Yeah, that's one of the most critical lines of the boat you'll see.
When I notch this out, I'm going to try not to use power tools this time.
That's what we
So give me a thought on the method you showed me with start with a saw.
Yep.
Fit it, but then should I use a sharp chisel to bring it in? Would you hand plane? What would you do to start bringing it back in?
Probably a chisel, yeah, either that or the little shoulder plane. So mark your line for where you think your finished shear clamp notch is going to be, cut on the scrap side of that line, and then use your chisel to just shave in and slowly bring it in. And if all is right and all your dimensions are correct, as you come down to that line, it should also land into a nice fair curve. So,
okay. Cool, thank you.
Yeah.
Here at the front of the boat, what I was planning to do with the shear clamp is it takes a lot of bending and twisting, and I was going to butt it up to the side of the stem. And my problem is there's just not a lot of material to bond to, and because I had some spring back when I molded it, I have even less. So I'm not sure, do I just butt it up to the back, butt it up to the side? How do you recommend I handle that?
you really want to notch the shear clamp through the stem, so you've got this kind of tapered landing, like a scarf joint really, but like sort of tapered, so you're kind of splitting the difference really. You're not entirely notching the stem for the shear clamp, you're not entirely butting the shear clamp to the stem, you've got this sort of tapered landing. So that's going to like reduce the stresses between the two of them where they meet, so you've not got a hard edge, but it's also going to massively increase the glue surface area of that shear clamp landing into the stem by quite a large factor actually. So it's quite an important thing to do.
Okay.
If you want to overcome the loss of material with the spring back of your stem, then you could put another lamination back on the inside to kind of gain back what you've lost in spring out.
Okay.
So you could put some more material there if that's also going to help you for landing.
When I returned to Minnesota, I decided to fill the gap behind the stem that was caused by the springback in my lamination process. I simply shaped some 3-inch wide boards with my belt sander. So what I'm going to do is I'm first going to bond these two surfaces together.
Then I'm going to put thickened epoxy on this surface and slide the whole thing in. Not really easy because I can't remove this.
I'd like to do is look at your full-size stem so that we can get a better view of it.
Yeah,
Let's do
let's take a
that.
look at that. Yep. So when you're bringing your topside battens into the stem, this is obviously a section of the boat where there's a lot of force coming in from all, there's a lot of stresses going on here. So if you land those just into the side of the stem, you can consider that, you know, your glue surface area at the end of that timber is this kind of size here. Whereas if you notch those into the stem like they've done here, you can see your glue surface area then becomes the full length of that, but also on the sides as well. So if you look at that down from above, you're probably talking about 4 times the glue surface area for notching those timbers in versus landing them on the side of the stem.
And then the shear clamp's especially important because that's at the tip of the boat. That's going to have a lot more force.
For a starter, it's quite a big timber that you're bringing in here, so there's a lot of stress in pulling that in. And again, you know, you'd have a slightly bigger surface area because you're coming back to there. So, but if we measure that, you could say, okay, that's 45 millimeters glue surface area. But then if you notch that in, you're extending that to just over 80 millimeters. So you've got almost double the glue surface area by doing it this way, which is like a kind of tapered scarf, really, I suppose.
Yeah. Well, and you just taught me how to use the saw,
Yeah.
the chisel, and the plane to exactly do that on your transom.
Yeah.
So I think we're in good shape.
So it's the same principle on the transom, really. When you're putting those posts in, you know, you could do like a small lap joint, you could do a butt joint, but when you do that taper, you're just increasing the amount of contact. And also kind of feathering out where the 2 timbers meet, so you've not got a hard intersection which is going to potentially crack. You've got a reducing thickness of the timber as the 2 blend into each other.
This way you can see how much more surface area I'll get as opposed to just butting it up right there.
Yeah.
No, I wouldn't be butting it there, I'd be butting it way back here.
On the side, yeah.
Yeah.
Because the outer face of as your timber comes in, the outer face of it is where this ruler is.
Yeah, all I'm going to do is butt right there.
You're in there. But of course you're only, for your topside battens, you're only a 12mm thick timber, so you're literally just that surface.
Yeah,
which is really too small for landing that.
Okay, then I definitely will notch this. So what I was explaining to Dan before is I don't plan on putting the Ilmor engine in here. I plan on making just an electric cruiser that won't go to that speed, but he explained to me that even at the lower speed, you still should have, especially up here, you should have it notched to get some extra force. So that is what I'll do, and I just spent 2 days with Dan learning how to do this. So I'm sure it will turn out just as good as your transom.
I think so. Got Bob off the power tools and onto the hand tools.
Temporarily.
Temporarily, yeah. When he goes home, it might be a different story.
If you saw my last video, you'll know that I measured all these shear clamp notches from the aft or back side of the boat, and I was adjusting them to go forward. What Dan explained to me is that is correct when the boat is curving inward at the front of the boat. But when you move to the back and all of a sudden it goes from curving in, going forward, to the curve goes in backwards, you actually need to take your measurements off the front of each frame, not off of the back. So if I use the example of frame 10 here behind the back seat of frame 9, I cut this 1.5 inches on the aft side, and because it's curving, it's less than 1.5 inches on the forward side. So what I'm gonna do to make sure I get this correct is I'm gonna remeasure. I'm gonna cut on frames, I'm gonna call it 10 through 13 on the front side, 1.5 inches in, and then I'll adjust with the fair or the shape of the boat. I'll adjust, which means if the front is 1.5 inches, the back side will have to be more than 1.5 inches deep to get this shear clamp to have the right curvature. So as you know, Dan Lee was nice enough to work with me and really gave me some good tips on how to use the handsaw and the wood chisels. So I went out and bought a set, and I promised Dan I would no longer do this fine work with my mini belt sander. So Dan, this is for you. I said I wouldn't use my mini belt sander. The final topic that Dan and I discussed was how difficult it was to bend and twist the 7/8 inch square batten that will make up the laminate for the shear clamp. Looking at the model, you can see that the top of Temptress is quite flat, while the side of the boat has a lot of curves and twists. Oh, were you expecting a different model? For that reason, Dan advised that I pause. He and Michelle Barrier will provide me with a simpler design where the shear clamp will run parallel to the top of the boat. Then, when the shear clamp laminate is in place, I will shape the twists and bends in the side of the boat with a hand plane. Till then, cheers.